Okay, welcome back. Happy Friday. Today we cover equations of lines. Next class is going to be our very first quest. So a couple of things about that quest. Number one, our next class isn't until Wednesday because this coming Monday is President's Day. So there are no day classes meeting on Monday. We won't meet each other on until Wednesday. So when we come in on Wednesday, the smartboard is not going to be on, and I'm not going to say anything to you as a class because it is a full period assessment. It's like kind of in between a quiz and a test. You're just going to take it the whole class, and if you finish early, you leave early. There's no like anything that we're going to do together as a whole, okay? So when you come in on Wednesday, you got to be prepared to do your best on this quest. The quest covers the material from classes or from lessons 1 through 5. You can see the lesson numbers right there, 1 through 5, which means that the stuff we're doing today, equations of lines, is not on the quest, okay? So just to be clear, slope, which was our topic last class, is the last thing that's going to be on this coming quest. So as you prepare for this coming quest, what should you do to make sure you're in the best place possible on Wednesday when you start it? Well, you got a lot of homework in my math lab that you've hopefully done. Maybe you still have a few more problems to do. Even if I don't know when the homework on slope is due officially, but you got to make sure you do it before you take this quest just so that you're prepared, right? So like, don't look at the deadline and say, oh, well, maybe I don't need to do it just yet. You want to do it to help you get ready for this quest. Also, after you finished all of the homework, there are a bunch of practice problems. You know that big practice packet I handed out a few classes ago? I'm guessing most of you haven't looked at it yet. This is a good time to start looking at it if you haven't done so. Again, the quest is on classes 1 through 5. So if you look in that practice problems column, and going from classes 1 through 5, you see that there's this collection of practice problem numbers that I've listed, right? These are the ones that are relevant to the first quest that we're taking, okay? And I want to be really clear about this. That collection of problems is as close to a sample quest that I can give you. I wrote the quest, I wrote those problems, there's a lot of similarity, right? So I'm trying to be very clear here. If you don't look at those problems, you are wasting an opportunity, okay? And in terms of other resources about those problems, again, if you go up on Moodle, you will find a PDF of full color solutions to every one of the practice problems. So it's not just answers like the answer key in the back. Hello. But full color solutions. And also on Moodle, you will find a playlist of me making videos that I have made going through every single one of these problems, right? So if you have any issues on any of these problems, you can get them solved. Even though we're not going to have class between now and Wednesday, you have the resources at your disposal to make sure that you know how to answer every single one of those problems. Any questions on any of that? Okay, so what's today? What's today's date? 13th, and today is Friday, so it's Friday the 13th. So it turns out it's your lucky day. I've made a change in the policy on the quests as a result of talking to a couple of my colleagues on Wednesday. My policy in all the other times I've taught this course has been that you just come in and you don't get to use any resources other than what's in your brain and a calculator. But after talking to some of my colleagues on Wednesday, we have decided that we are going to let you guys use a one-page sheet of reference material of your own creation. You'll have that with you when you take this quest, and you'll do the same thing for the future quests and tests, okay? See, Friday the 13th isn't all bad. So I will tell you that making a good reference sheet should be considered part of a good study plan in prepping for this thing. Don't come here on Wednesday morning and 5 minutes before the quest, go across the hall and frantically write down a few formulas and equations or whatever. Making a reference sheet takes time, but it's part of your study plan. I can oftentimes tell how well a student is going to do on a quest or a test just by looking at the quality of their reference sheet. And the people that make the best quality reference sheets often don't even need them. They've prepared so much for the thing that it's just there, but they don't actually end up using it. So things that you're allowed to put on this one-page sheet of reference sheet, you can put formulas, you can put equations, you can put definitions, you can put problems worked all the way out, start to finish. Right? Little notes to yourself, things that sometimes you get tripped up on. So take it seriously, making that reference sheet. That is a good part of your study plan. Any front and back, one page, 8.5 by 11. Don't come in with like a poster board. Any questions on the study sheet? There's nothing that can't be on there. Anything you want. All I want is that it's not a photocopy of like somebody else's study sheet or a photocopy of my notes or a photocopy of the book. Just write stuff by hand or type stuff on your own. But like I said, making it is part of the studying. So I want you to like really have it be your own. Good question. Any other questions? Okay. So with all that behind us, I think we are now ready to go to page 41. So you're on page 41. I'm just a couple of pages before you. You don't need to go to this page, but I just want to remind us of something we did last class during the activity. There was this example where the graph here gives the Y value is the value of a car in dollars, and X is its age in years. You guys remember looking at this one last class? And so what was the, like I see a 10,000 up here, is this y-intercept? What does that mean in the context of this problem? So there's no value of the car at the 10,000 point? I think there is a no value of the car point, but I don't think it's this one. Yeah, when we first leave the lot, meaning the car is 0 years old, the value of the car is 10,000. And then as soon as you leave, the value of the car starts to decrease, right? Until we get over to here at this 20 moment. Irene, what's going on at 20? At 20 years is worth nothing. That's the point where the car has no value, right? Okay. And what you guys did is you calculated the slope of this line, and I will remind you that you got negative 500 was the slope of this line. And what you wrote a sentence representing that, and you said, oh, that just means the car loses value or depreciates. Some of you knew that fancy word, $500 per year, losing because of the negative, right? And then I asked you to come up with the equation of this line, the equation of this line. So just to remind us in plain English, here's what you did. You said, okay, what's the starting value of the car? 10,000. So it feels like we start with 10,000, right? And then we're losing, so minus seems like the right thing. And we're losing 500, but not just one time, but 500 every time, every year. And so how was our, what did we stick on here? What was an X? You guys remember doing that the other day? I'm going to rewrite this in a slightly different form. It's equivalent. It still says the car starts at a value of 10,000 and at positive 10,000, right? And it loses 500 every year. So it's the same equation, it's equivalent. But the way I've written it the second way should remind you maybe of an equation you've seen before that we will officially see today. Mx plus b, right? You guys have probably seen this before that moment. But I want to point out to you that we did not talk about y equals mx plus b last class, and yet you were able to come up with that equation without thinking about this mysterious formula. You didn't pull it out of your hat, right? You just thought about it, starting at 10,000, losing 500 a year, and you wrote that equation. So it was a natural thing. So even though you've got this mx plus b memorized, probably from some previous math class, I just want to make sure you're clear. It's not a mystery. It's something that you created without having this pre-prepared formula at your fingertips last class. Okay, so that's our kind of review. Let's go forward now again to page 41, and we'll start with our daily summary. Cody? Okay, so that slope intercept is that mx plus b, which we will see today. I'm going to read number 0 here. It's an important note. It says we are skipping sections 2.1 to 2.3 in the textbook. You see that we're up here at 2.4 and 2.5 today, and we're never coming back to 2.1 to 2.3 because those sections cover a topic called functions, a concept that isn't technically part of the curriculum for this course. I'm not saying it's not important, just saying it's not part of what we need to do this semester. If you take college algebra 107 next semester, you will spend a lot of time being introduced and gaining comfort with functions. From this point forward, however, you might see the word function in your textbook, because in your textbook at section 2.4, they assume you saw sections 2.1 to 2.3. So they're going to assume you know this word function, and they're going to assume that you have seen some notation, this f parentheses x, g parentheses x, h parentheses x, which you have not seen, at least not according to our class. So I'm giving you the translation that you are going to do. Anytime you see the word function or you see that notation. If you see the word function, in your mind, you will mentally replace that with the word equation. If you see the word function, you're going to replace it with the word equation. I am not going to use the word function in this class. You're not going to see it in my packets here, but you're going to see it when you're doing your homework. Okay? And I just need to make sure you know how to translate it to something that you know. Ramses? Yeah. So I think that question that Ramses is referring to is just one other announcement I needed to make. Remember I had said that I assigned one homework problem and it was premature and I gave you the answer. I said, I just wrote it up on the board. I said, type this answer in for problem number 5 on homework 3. You guys remember that? Okay. So I think Ramses, that's the question you're talking about. And part of why it was assigned in the wrong spot was this P parentheses X business. But another issue, and I only realized one of my colleagues pointed it out on Wednesday, is that when I gave you the answer to that problem, that was the version of the problem that I answered. But every time you go into my math lab, it changes the numbers a little bit. And so I'm assuming that you guys all got that wrong. So I just want to let you know, I'm going to go in and I'll give you all credit for that homework. So don't worry about that one. I'll remind you it was homework number 3, problem 5. Don't worry about it. You probably got it wrong. I will give you all credit for it. That's my fault. Okay, so we are doing more translating. If you see the word function, you change it in your mind to the word equation. If you see any of these mysterious symbols, F parentheses X, G parentheses X, H parentheses X, in Ramses's example, it was P parentheses X, any of that kind of notation, you're going to mentally replace those symbols with a Y. Just simply change all of that stuff, F parentheses X, into the single letter Y. So for example, if in your My Math Lab homework, you read, consider the function F parentheses X 3X minus 2, we change the word function to equation. We change F parentheses X to Y. And so that translates to consider the equation Y equals 3X minus 2, which is a whole lot more familiar to us and doesn't bring us into this world of functions. Everybody clear on that? Really important because you're going to be seeing this notation and My Math Lab assumes you know what it is, and I'm telling you that we don't officially know what it is, so you make those translations. Questions? Okay. Number 1, let's go to Lucas. Okay, so again, I think that's something that many, if not all of you, have seen before. M is the slope, B is the y-intercept. Let's use it in number 2. Can we go to Savannah? Okay, so all we have to do is recognize what that y equals mx plus b means. The x and the y are going to be part of our final answer. I'm going to copy those, but I left a little bit of blank space. The m, again, represents what? Slope. What is the slope in this problem? Negative 2/5. We'll change the color here. Negative 2/5 goes right there. The b in the mx plus b represents the y-intercept, which is just the number 3. Plus 3, and we're done. That is the equation of the line that has a slope negative 2/5 and has a y-intercept of 0, 3. Questions on that? Okay, so that version of using the mx plus b is pretty straightforward. It's the easiest kind of a problem you might get. We're going to tackle a much tougher problem. 3, Ben?
Let's find an equation on the line that passes through the points.
Okay, so I give you 2 points. So just imagine plotting these 2 points. You don't even have to worry about really where they are exactly, but you plot these 2 points. How many lines are there that exist that touch both of these points? Just the one. One line that connects any 2 points, right? And our job is to find the equation of that line. So what made number 2 easy was that we were given the slope and we were given the y-intercept. 2 gifts. We're not given either of those things in this problem, right? We're given these 2 arbitrary points. So the very first step is to find the slope, right? I mean, that's one of the things we need anyway. Okay, so in number 3, on the left-hand column here is a step-by-step process all written out for you to look at later on. We're not going to read it, I'm just going to explain it, but essentially I'm going to be paraphrasing what's up there. But you got it for a reference. The right-hand column, I put a big blank rectangle over mine. I don't know what you're going to do. Like cover it up. Like I want us to actually do this as opposed to like reading it. You can read it for later. Maybe on the previous page there's some blank space. You can like do the work that we're about to do over there. Is that fair? So just find some blank space someplace for us to do the work that's typed out for you to reference later on. Okay, so it says circle both coordinates of a point on the line. If you have 2 points given to you, pick either point and circle its coordinates. We have 2 points. I'm just going to circle one. Doesn't make any difference which one we pick, but let's all pick the same one. I'm choosing the first one. Part B says write down the slope of the line. Okay, sometimes there's work involved in finding the slope of the line. Let's do the work in this case. M equals. So remember, slope is a fraction. We got to think about the x changing. We got to think about the y changing. Which one goes on top? Is the y, right? It's a change in y over the change in x. I'm going to copy that formula, which technically we didn't actually write out yesterday or last class. We talked about rise over run, and we talked about change in x over change in y, but really change means subtract in mathematics. So we're just going to be subtracting some numbers here. Okay, I've got 2 points. One of them is circled. Ignore the circle for a moment, and we're going to start doing the slope calculation. So upstairs, what are we putting? -5 minus 4 is good. I'm going to put an arrow in that direction. Now, Ben said -5 minus 4. Just as well, what could we have done instead? 4 minus -5 makes no difference as long as we're consistent in the order we subtract. But Ben said this order, so let's do that order. Seems like it would come out different. We saw last class, you weren't here last class, but we saw that it turns out it's going to come out exactly the same regardless. As long as you're consistent for the whole fraction will come out the same. Yeah. Okay, divided by. Now, because of the choice that we made upstairs, what do we have to subtract? What order do we need downstairs? 2 minus -1. Gotta be consistent in the order we subtract. 2 minus -1 equals. Okay, so upstairs we have -9. Downstairs we have 2 plus 1, right? So that's 3. And so the slope turns out to just be -3. Okay, so we calculated the slope, that's old. The rest of what we're doing here is new for today. Part C says write the equation y equals mx plus b. We're just flat going to write it with all of those symbols. I probably should preface this by saying that what I've written out here contains all of the details for solving this kind of a problem. I suspect that many of you have solved this kind of a problem before, and some of you are pretty darn good at it already. And so I just want to say that all I need is you to be able to get to the final answer. And if you don't want to do all of the, like, we're going to do a lot of detail work here, you don't need to do that. Just need you to get to the final answer. But I want to make sure that everybody can get to the final answer. So I have written out with a lot of detail what I think is a foolproof way. So again, if it feels like there's more steps than needed, don't sweat it. I'm not requiring them, but I want to make sure that we catch everybody here. Okay, part D says in the equation, you're going to replace the m with the slope that we just found and write the equation y equals some number times x plus b. Some number times x plus b. What was the slope number that we just found? It was -3. So we're just going to copy this purple equation again. But instead of that m, we're going to put a specific number. What number? -3. Everybody with us so far? So it's just one small change the slope to the number that we found. Okay, there's one other piece to this puzzle, and that's to find this b. We don't have the y-intercept, unfortunately. And a real common error is to say, oh, great, let's see, the y-intercept is 4, right? That's the y-coordinate in this point that we circled. How do we know the y-intercept is definitely not 4? The x isn't 0, right? We know at the y-intercept the x is 0. And unfortunately, neither of these points is the y-intercept. So not only is it risky, like it's going to be flat wrong to just pick that 4. Like unless it's a 0 in the x, it's never going to be 4 as the answer here. So the rest of this process is to do the work to find the y-intercept. There's just one kind of funny step. It says put a star next to this equation. I don't know why, but we're putting a star. We're going to refer to that equation in a couple of steps. Okay, part E says rewrite the equation from the previous step, but replace the x and y in that equation with the coordinates of the point that we circled all the way back at the beginning. So just because I want to keep everything on the screen here, can somebody remind me of the point that we circled? Was it -1, 4? Okay, so I'm just going to write it there. That's the one that you have circled. We're going to recopy this purple equation, but instead of the x and the y, we're going to put those coordinates. So the y becomes 4 equals, I see a -3, I'm just straight copying, times the x becomes -1. And then the plus b is the thing we're after, it gets copied. And so this is now the version of the equation we just wrote down. Some number equals some number times some other number plus the b. The b is the only letter that should be in that equation. And since the b is the only letter, we can solve that equation and find b. So that's what part F tells us to do. So let's see, 4 is equal to -3 times -1 is +3 plus b. Subtract the 3 from both sides. B is okay, and then the last step here in G, it says finally plug this value for B into the equation with the star. That's why I put the star there, just so we could reference it. So my starred equation is this one up here. It's got the blue star next to it. So this equation is the one that's getting copied down. All we're going to do is change the B into the number that we just found. But the Y, which became a 4, is now back to a Y. So it's Y equals. The -3 is still there. The x is back to an x, but plus, and the only thing that's changing is the b becomes a number now, 1. And so that equation has this form, y equals some number times x plus some number. Ramses. It turns out it would come out exactly the same. The process would look a little bit different in the middle, but we're all going to get exactly that equation regardless of which point we circled at the beginning, which is a surprise. But it turns out it comes out to be exactly the same. Okay, so there's our equation. And like I said, I think some of you are probably already awesome at this process, and you don't need all the details that I've put up there. But it can be darn confusing because some letters become some numbers and then they become letters again, but some letters become numbers and then stay numbers. And so it's just really easy to sort of lose sight of which ones are the ones that are supposed to be numbers at the end and which ones are supposed to be letters. The X and Y, they're supposed to be letters. They're in my final answer. But the M and the B, ultimately we need them to become numbers, -3 and 1 in this case, okay? All right, number 4, let's go to Christian. Great, so here's a brand new equation. Okay, so y equals mx plus b and this new one will both get you to the same answer. They'll both get you the equation of a line. And so when I was back in school, I was trained in both of these equations. But I think it was this second one that got more attention. But at some point, since I was in school 100 years ago, I think there's been a shift. And so if you were in high school fairly recently, I think the y equals mx plus b is really what got more of the attention in your math class. And this guy got little, if any, attention. So I'm not here to change that. Again, all I care about is that you can get to the equation of a line. And so either of these tools will solve the same problem. I'm never going to force you to use one or the other. I suspect that most of you are going to do the mx plus b because that's what you're most comfortable with. I'm just going to show you one example with this other equation. But again, never going to force you to use it. So number 5 says, let's find an equation of the line that passes through those points, exactly the same points we had before, but instead we're going to use this new point slope equation. Okay, so for this one, we're just going to read the process instead of doing it from scratch. So the first step is to find the slope. It's exactly the same points, so it's exactly the same calculation and exactly the same -3 that we got before. The next step is to start with the new equation, that y minus y1 equation, and change the m into the number that we just found, which was -3. And so the m became -3 right there. Everything else in that highlighted yellow equation is just copied straight over. Yeah? And then the next thing that we do is we change the x1 and the y1, because the x1 and the y1 are just supposed to stand for the x and y coordinates of one of our points. And it makes no difference which one we call it. So I'm just going to say that's the x1 and that's the y1. I'm going to write this, not that it's necessary, but x2 and y2 would be like an appropriate name for the other guy. And all we do is we go back to that, like yellow equation here, and we change the x1 into -1, and we change the y1 into 4. And so I'll circle the x1 became -1, and the y1 became 4. Everything else was copied. And there's a fundamental difference here because the x and the y stayed exactly x and y, right? But on the previous page, it was the x and the y that got changed to the -1 and the 4. So it's different. Okay, so we've got our equation here. Y minus 4 equals -3 times x minus -1. And it turns out if you solve that equation for y, we're going to get exactly the same thing we got on the previous page. So let's just quickly follow the process here. Minus minus becomes plus. Okay, so that's reasonable right there. So that's our x plus 1. And then what can we do with that -3? We'll distribute it. So -3x and then -3, right? That's there. And then finally solving for y. What do I do to move that -4? Add 4 to both sides. When you add 4 to this number right here, what do you get? You get +1. And so that equation should look familiar. Y equals -3x plus 1 is exactly the same equation we got before. Like I said, these are two different tools that solve the same kinds of problems. So of course they'll give us the same answer. Okay, I think that is good. All right, let's go to the activity, which is on the next page. Raise the flag if I can help.